In this video, we're going to be talking about solving an equation involving logarithms on both sides. So we have two steps. We want to condense any multiple logarithms on either side into one logarithm. So in other words, like this example here has two, we'll combine that into one. And then we will ignore the logarithm, and I'll show you why we ignore the logarithm, and then solve the resulting equation. Okay, so before we get into that, we call a rule that says if you have a to the log base a of x, that's going to be equal to x. Okay, so in other words, if you have this base down here and you raise it to the exponent of log base a, same number of x, then this logarithm and this exponent will cancel out. Okay, it's similar to the idea that ln and e will cancel out to 1, or e to the ln of 1 would cancel out to 1 as well. Okay, so we're going to use that. So we look at this first example, and we have log base 9 of 5x minus 7 equals log base 9 of 6x minus 4. So what I can do is raise both sides and put a base of 9. Okay, so it'll be 9 to the power of log base 9 of this, and 9 to the power of log base 9 of this stuff. And when that happens, we can drop those logarithms completely off, cancels with the 9, and you're left with 5x minus 7 equals 6x minus 4. And then we just solve for x. Okay, so I will subtract the 5x to get it over to that side, and I will add a 4 to get it back over to the left side. Okay, so that gives me on the left side negative 7 plus 4 is negative 3, and 6x minus 5x is equal to x. So we have our answer of negative 3. Now be careful on these problems, because sometimes you can come up with an answer and it's still not correct. Like you did all the math correct, but you plug it in, it still doesn't work. And that's because logarithms have a very limited domain. You can't plug in 0 into a logarithm, and you can't plug in any negative number into a logarithm. So if you plug your number in and the entire inside turns negative, then it's automatically not going to work as a solution. All right, so let's go up here. We have log base 9. I'm going to plug the negative 3 in, so I get 5 times negative 3 minus 7. And then on the other one, I get log base 9 of 6 times negative 3 minus 4. Okay, so this becomes negative 15. And we do negative 15 minus 7, and that becomes negative 22. So immediately we have a problem. We cannot, there's no value for log of negative 22 because you can't put negative numbers inside. So it's not going to work. Let me just finish up the other side to show you how it would finish if we were solving it. So it'd give you negative 18 minus 4 is negative 22. Okay, so you get something that actually works, like it's an equal, but the problem is both of these are undefined. So even though both sides are equal, if you plug this into the calculator, it would not give you an answer. It's undefined. So we're going to call this no solution. We found a solution that should have worked, except it wasn't in the domain of the logarithms. Okay. All right, let's look at the next problem over here. We've got log base 6 of x plus 8 minus log base 6 of 20 equals log base 6 of 14. So the first thing we're going to do, since we have multiple logarithms on this side, is bring them together. There's a subtraction sign. They have the same base, so we can bring them together by dividing the inside. So I'll get log of 6 of x plus 8 divided by 20. Okay, that's the quotient rule, equals log base 6 of 14. Okay, I can do what I did last time. This time it'll be a 6 that I'm raising to the power, so that cancels and that cancels. So we're basically ignoring the logarithm to find these solutions, potential solutions. X plus 8 over 20 equals 14. If we multiply the 20 on both sides, 14 times 20 is 280. This cancels here, so you get x plus 8 equals 280. And x is equal to, if I subtract the 8, that'd be 272. Okay, so 272. Let's see if it works. We can plug it into this equation before I did the 6's there to see if it's true. Okay, so we get log base 6 of 272 plus 8 over 20 equals log base 6 of 14. Okay, so if I do all this math and it turns out to 14, we found a good solution. So this 272 plus 8 becomes 280, and 280 divided by 20 is 14. Okay, so we get log base 14, or base 6 of 14 on both sides. So this is a good solution. X equals 272 is a good solution for us. Okay, let's do a couple more. Okay, so we've got ln of x equals ln of 2 plus ln of x plus 3. Remember, ln is the natural logarithm. It's the same thing as saying log base e of x. Okay, and also remember what we said at the beginning, that if you put an e underneath an ln, it'll make the e and ln cancel out. But first we have to bring these two logarithms together, so they're being added. So on the left, I have no changes, but on the right side, I'm going to multiply these inside. So ln of 2 times x plus 3. So we distribute that, that's 2x plus 6. So let me write that down. ln of 2x plus 6. Okay, and then we can raise both sides to the e to the ln, e to the ln. That makes them cancel. So you get x is equal to 2x plus 6. Let's move that over. So I get, I subtract 2, it'll be negative x equals 6. So x is equal to negative 6. So let's try the solution and see if it works. Let's plug into this one before I did the e power. So it would be ln of negative 6. That's immediately a problem, because you can't put a negative into a logarithm, equals ln of, let's see, plugging in here, plug in negative 6 in here, that's negative 12 plus 6 is negative 6. So just like the last problem or the first problem we did, it gave a solution that actually gives us the same number inside. The problem is this answer falls out of the domain of logarithms. So even though it came up with an answer, this one's going to be no solution. Okay, last problem. We have all ln's again. These two are being added, so the first thing I'm going to do is bring those together. ln of 5 times x plus 2. So we use the product rule. And then distribute, so ln equals 5x plus 10 equals ln of 14. So now we can e both sides, like we did the last problem. Apply e as a base to both sides, and it will cancel out to give us the inside, which is 5x plus 10 equals 14. I subtract the 10 from both sides, and that gives me 5x equals 4. And then I divide both sides by a 5, and I get x is equal to 4 over 5. Okay, let's plug that in and see if it works. I'm going to plug it into this part right here before I applied e. So it'll be ln of 5x plus 10, but I'm putting this in its place, so 5 times 4 over 5 plus 10 equals ln of 14. Okay, so if I can show that the inside here is equal to 14, 14 is in the domain of a logarithms because it's positive, so let's see what happens. These 5's cancel out. You get ln of 4 plus 10 equals ln of 14. 4 plus 10 is 14, so this works. This is a good solution.